All right, good evening, everyone. Welcome to another session for statistical techniques. My name is Kuda. I think for most of you guys who came through last week, I think you now know a bit about me. So tonight, we just want to continue from where we left. If it's your first time coming through tonight, just make sure that you get a hold of James. He will give you a recording of last week, the one that we did last week as an introductory lecture, and then also he can give you also information about the payment and so forth. All right, so tonight, let me try to share the screen right here. Okay, just give me a moment. Okay, I think we can be able to continue from where we left. All right. All right. So can you confirm if you can see the slides? Uh,
Yeah.
Yes, we can.
all right. Thank you so much. Thank you, ma'am. All right. So last week, basically, we were just talking about some basic intro. Why statistics is very, very important for your module. And I want to believe that most of you guys, you had an idea. I hope I'm audible. You had an idea of why this module is very, very necessary. So now, what we're going to do today, I'm just going to do what is called a rundown of topic where we are going to start with calculations. I'm not so sure which unit is it in the module guide. But like I said last week, I'm starting first with focusing on calculations because that's 99% of the module. So I want to focus more on what I know is gonna come, and then later on we'll finish with the other theory that we didn't focus on. Like I said, the theory is not linked to the calculation, so that's why I left them. All right, so today we're going to look at what we call measures of central tendencies, all right? So, by definition, a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of data. Remember last week, we said there are two types of statistics, right? We said there is descriptive statistics. Descriptive statistics, this is statistics that describe data. Then we've got inferential statistics, is statistics now that are done using a sample and then is generalized about a population. And I gave examples of both. So now measures of central tendencies, this is example of descriptive statistics. That's why we say that it is a single value that attempts to describe data. So you are describing data using one value. Very good example of measures of central tendency is your average. But in this module, it's not known as an average. It's known as a mean. Okay, you see this word here. That's your average. So in this module, when you talk about average, right, that's your mean. So basically, the measures of central tendency, they help you to find what we call the middle or the average of the data set, right? So there are three commonly used numerical measures of central tendency or a central location of a data. So we're going to look at the mean, we're going to look at the median, and we're going to look at the mode. So those are the three things that we're going to look at under this topic right here. So before I go any further, let me describe what we call two types of data, because this is gonna be very, very important from the next slide going onwards for this unit, right? So if you don't get this part here, please don't let me proceed until you understand, because you understand why we are talking about these two types of data when we get to the calculation on the next slide. So we have what we call ungrouped data. Then we have grouped data. So ungrouped data, this is data you first gather from an experiment or study. This data is raw, right? It's not sorted in any way. It's not grouped in any way. It's data that is given as individual data points, right? So when you are given a list of data, of numbers, right? If they are not sorted, if they are not grouped, then that type of data is ungrouped data. It's like your lecturer when they get into the lecture room and says, give me your shoe size and I'll write it down. When someone is given that list of shoe sizes, that type of data is raw data. That type of data is ungrouped data. They just recorded down the shoe sizes, but they did not what? Group it. So that's the first type of data. The second type of data is what we call grouped data. So grouped data is data which is given in bundles. It's data that is given in categories. It's data that is given in intervals. So example, your lecturer comes into the classroom when he says, I'm grouping people based on their shoe size. Now, when they record that down, that type of data is grouped data because it is data that is showing the grouping of people based on the shoe size. So that is the two types of data that we have. So ungrouped data is given as individual data points. Grouped data is given as histograms or frequency tables. All right. Are we on the same page, right? Before I start with this example here. I think that was very, very, very clear. Right. Okay, let me see. All right, was that the question? I saw someone try to unmute here. Okay, let me just give me one.
No, it wasn't. Just wanted to say we're okay.
All right. Thank you so much. Thank you. All right, for the confirmation. All right, so let me proceed. All right, so now let's look for mean, mode, median for ungrouped data. So when you are calculating your mean, when you're calculating your mode, when you're calculating your median, the formulas differ based on whether the data is grouped or ungrouped. You will see when we proceed. So that's the reason why I wanted to separate those two types of data. So now we are first going to focus on ungrouped data. So when we are given ungrouped data, the way we calculate mean, mode, and median is different when we are given grouped data. So grouped data, you have your own way of calculating mean, mode, median. Ungrouped data, you have your own way of calculating mean, mode, and median. So let's look first at ungrouped data. So mean or average for ungrouped data, it's given by this formula right here. X, this hyphen on top. I know it's very weird to say hyphen and then say on top. So X with a dash on top or hyphen. I don't know if it's, yeah. I think the dash is hyphen. So it's on top there. We call it X bar, right? For those that have done statistics, I think they know they've heard this term X bar. So this dash here is called bar. So X bar. So when you say X bar is equals to, so this is the mean. This is the standard notation of average or mean in statistics. But you don't need to know this. It doesn't matter. It doesn't affect anything in your examination. They'll never say X bar whatever. They'll tell you literally calculate the mean, calculate the whatever and things like that. So I'm just explaining it for the sake of explanation. So mean, it's equals to the summation of all the observation over the number of observations. So let me explain this using this example. So to illustrate, take for an example, the marks received for a spelling test For 7 learners. So the first learner gets 85, the second 48, the third 52, the fourth 64, the fifth 64, the sixth 80, and the seventh 75. So when we are calculating the mean, when we are calculating the average, what you do is you add every individual test mark, right? So you take your 85 and you say 85 plus 48 plus 52 plus 64 plus 64 plus 80 plus 75. That is what is meant by summation of all observations. So you add all the values, right? There. Then you divide by the number of observation. So the observation in this case is the mark. So you sum all the marks. Then the number of observations is how many times did you record the marks. So in this case, we recorded 7 marks for different learners, right? So after adding all the marks, you divide by the number of people that correspond to these marks. So basically, that's how you do average actually, right? This is how when we say calculate the average, you calculate all the values together and divide by the number of people. So in this case, that would be 66.86. So if it was metric pass rate, then this will be the metric pass rate, right? Let's say for that module. So this is how you calculate mean. So this one is very, very easy because that's how you calculate your average. And everyone, I want to believe they know how to calculate an average here. Now, let's look at the median now. Median is a bit different. So for some people, this is going to be a first time hearing about this. So median, basically, it is a middle number that separates the data into 2 equal halves. So a median it's a number in the middle of the data that divides the data into 2 equal halves. But now, for you to calculate the median, there are certain things that you need to do, right? One, you need to arrange the data in ascending order. So what it means is you order your data from the smallest value to the maximum value, right? Then after you do that, there is a way that you try to identify the median, right? When you get the median, then like I said, it divides the ordered set of data values into 2 equal halves. So that means that 50% of the data lies below the median and 50% of the data lies above the median. So after you have arranged your data into ascending order, meaning the smallest to the maximum, then the next thing that you need to check is the list of the values that you have been given, the total number, right, which is n. The total number of the values, is it odd, or the total number of values, is it even? Like, for example, that sample test, there were 7 people that took part. So now you're checking, is 7 an odd number or is 7 an even number? Remember, odd number, right? When we talk about odd numbers, for those that no longer remember, right? I think this is one of the things that we were taught in primary school, right? An odd number is a number that is not divisible by 2. What does that mean? If you divide a number by 2 and it leaves a remainder, that's an odd number. What is an example of an odd number? 3. When you say 3 divided by 2, you get 1 remainder 1. So as long as you divide by 2 and get a remainder, that is an odd number. So it's not divisible by 2. Then what is an even number? An even number is a number that is divisible by 2. For example, 2 divided by 2, you get 1. 4 divided by 2, you get 2. Remainder 0. So every number that is divisible by 2, it's an even number. Every number that is not divisible by 2, that's an odd number. So now that I've explained this, so what you need to know, the next stage after you arrange your data in ascending order, you want to check if n is an odd number or n is an even number. So if n is odd number, like the previous example, it's 7, then your median value lies in what we call n plus 1 over 2th position, meaning that n, this n here is the value of the sample. So in this case, you say 7 plus 1 over 2. So this will be 8 over 2. Then this will be 4. So the value on the fourth position, all right, that will be the median. The median is not number 4, but we are saying when the list is what is sorted in ascending order, meaning from the smallest mark to the maximum to the highest mark, the value, the mark that is on the fourth position, counting from the left. I'm going to do an example on the next slide, so don't worry. I'm just for now explaining, then we're going to do an example on the next slide so that you understand. So fourth position, you'll be counting from the left side, right? So this is how you calculate the median value using if n is odd. So you say n plus 1 over 2th position. However, if n is even, the median value is found by identifying n over 2th position. So let's say we have number 8 as n, right? So if we want to find median, we identify n over 2th position, meaning in this case we say 8 over 2 to get fourth position, right? When you get this fourth position, you wait, right? Because there's another step that you need to do. So when you get this position, what you do, you say, and then averaging the data value in this position, meaning the fourth position, with the next consecutive data position. So what it means is we've got first position, we've got second position, third position, fourth position, fifth position, sixth position, seventh position, eighth position. So this data is weird. Okay, let me start by the first one where we had 7, right? So if you say, so let me start with the one that had the 7 here. So when we say n plus 1th position, right? What you are doing is you are saying, so we found that the median lies on the fourth position. So when you count from was this data is sorted, 1, 2, 3, 4, 5, 6, right? So when you count from the left, so you say 1, 2, 3, 4. So it means this value here, the value on the fourth position will be the median. Remember, the median we are saying is the value that divides the data into 2 equal halves, right? So this value, does it divide the data into 2 equal halves? Yes. Why? There are 3 positions on the left side and there are 3 positions on the right side. So the number of values on the left are equal to the number of values on the right side. So that this means that this position here is a median position. However, in the case, let's say, where we said we had 8 positions, where we say n is equals to 8. If we find this fourth position here, if we say this fourth position, if you don't go to the next value, where the next part where it says you then average the data value in this position, meaning the fourth position, with the next consecutive data. If we just say, okay, fourth position is our median, this will not be a true median, because if you count the number of the points on the left side, it will be 1, 2, 3, but the number on the right side, it will be 1, 2, 3, 4. So this will not be a median, because the number on the right side, they are more than the number of the left side. So that's why now they are saying if n is even, you first find the n over 2th position. In this case, it will be the fourth position. So once you get this fourth position, you add it with the next consecutive value. So what you do is, after you find the value on the fourth position, you add it with the value on the fifth position. So what it means is you are adding fourth position plus fifth position then you divide by 2. So the value on the fourth position plus the value on the fifth position, you divide by 2. The value that you get there would be what we call the median, right? So in this case, let's say, right, uh, let's say when we add this and this, right, we get, let's say, A. When we add fourth position plus fifth position divided by 2, we get A. So A now is in the middle of the fourth position and also in the middle of the fifth position. So what it does is it then divides this data into two equal halves. So if you go and read the values on the left side of A, we've got 1, 2, 3, 4. If you count the values on the right side of A, we've got 1, 2, 3, 4. Okay, so while this is fresh, let me give a practical example. Then if anyone has not understood this, let a question come after I've done the examples, right? Because I know the example that I gave on the previous slide might not be deep, or might not go home, but this one go home, right? All right, so let's look at an example here. So it says, find the median number of cars sold per month. So this is a car dealer that sells cars, right? So they want to find the median number of cars sold per month by a dealer over the past 9 months, right? Based on the following monthly sales figure. So here we are told that N is equals to 9. Is that right? So when we are given this data, remember this data is not sorted because the value that is starting is 27, but yet inside we've got another value for 24. So the first rule, when you want to calculate the median, right, what you do is you sort the data in what? You sort the data in ascending order, all right? So when you sort the data in ascending order, you start with the smallest value and you go to the maximum value. So the smallest value is 12 and the maximum value is 42. Now, the next thing we want to check is n odd or is n even? What is 9? Is 9 divisible by 2? No. So obviously, this make n odd. So n is odd because it's 9. 9 is not divisible by 2. So when n is odd, that's where we use the formula n plus 1 over 2. In this case, it will be 9 plus 1 over 2, which gives 10 over 2, which will give us the fifth position. So what it means is the median, right, is on the fifth position, right? The median is on the fifth position. So what does that mean? So if we start to count, from the left, so this is the first position, second position, third position, fourth position, then the value that is on the fifth position, that is the median. If we verify, let's verify if that's correct. How many values are on the left side of this value here? We've got 1, 2, 3, 4. Okay, let's count values after this middle value here. 1, 2, 3, 4. So the numbers on the left side of the median value are the same as the values, the number of the months that are on the right side of the median value. So this proves that this is a value that is dividing the data into two equal halves. So how do you interpret this value? So the median value therefore lies in the fifth data position. That's what we identified. Thus, the median monthly car sales is 34 cars, right? What does it mean? This means that there were 4 months. 1, 2, 3, 4. There were 4 months when car sales were below 34, which is correct. 12 is below 34. 23 is below 34. 24 is below 34, and 27 is below 34. So now we are saying there were 4 months where the car sales were below 34 cars per month, and 4 months when car sales were above 34 cars per month. Is that correct? That's correct. Because 38 is above 34, 40 is above 34, 40 is above 34, 42 is above 34. Now, this doesn't have to be necessarily consecutive months. Because remember, we sorted the data in the smallest value to the largest value. So obviously, the consecutive months was not, the issue of consecutive months was not considered here, right? So when we say 4 months where the car sales were above 34, it doesn't mean that it was 4 consecutive months. We're just saying in general, there were 4 months from the period of 9 months where the car sales were above 34 cars per month. So that's how you interpret the median and an example of where you can use the median. So we were dealing here with odd numbers, right? So let's look at an example where they are even numbers. So it's the same example, but we have added 1 more month, right? So find the median number of cars sold per month by a dealer over the past 10 months based on the following monthly sales figures. So it's still the same 9 months, but we have added 1 more month, right? So obviously we can't deal with this data. We need to sort this data into ascending order. So you start with the smallest value, you end up with the maximum value, right? But if you count them now, they are 10, meaning it's even number. Now remember, if it's an even number, right, we use the formula where you say you first find n over 2th position. So let's do that exactly. So we are saying 10 over 2, you get 5th position, which is this 5th position here. So let's count up until we get to the 5th position. So first position, second position, third position, fourth position. So this is the 5th position. So like what I was saying, this is not the median yet. Why? Because this position does not divide the data into 2 equal halves. Is that correct? So let's count on the left side. We've got 1, 2, 3, 4. But on the right side, we have 1, 2, 3, 4, 5. So that's why I was saying, when you just say n over 2, when you find that position is not, right, the median position. There's another step that you need to do. All right, so let's do that step. So now that we have identified this position, right, we need to identify the next position after this position, which is this value, which is this position here. So what you do is you find an average of these 2 positions. So what you do is you take this value 27, you take this value 34, you add them together, you divide them by 2, which is what we did here. So we took this 27, we took this 34, we added them together, we divided by 2, right? And we got 30.5. So what we did is you average the 5th position, the one that you find by saying n over 2. Then you average it with the next position, the value on the next position. So if 5th was the position that you got, then you go to the next position, you take the value, and then you average the 2. So when you get now this, what does this mean, right? So what this means is when you get the average is the number that is in between. So the average we said is 30.5. So this is 30.5. And remember, 30.5 is in between 27 and 34. So what it means is this 30.5 becomes the median. So it means this value in the middle is the one that it becomes the median that divides the data into 2 equal halves. So is that correct? Let's count the values on the left side of 30.5 and let's count the values on the right side of 30.5. So we've got 1, 2, 3, 4, 5. 5 values below 30.5. Now let's count how many values do we have for above 30.5. Then we have 1, 2, 3, 4, 5. Right? So that's still the same thing right there. Right? So what we do now is we need to interpret. So thus the median monthly car sale is 30.5, which is correct, what we got. This means that there were 5 months where car sales were below 30.5 per month. Is that correct? That's correct. 12 is less than 30.5. 18 is less than 30.5. 23 is less than 30.5. 24 is less than 30.5. And 27 is less than 30.5. So which is correct? And now we have 5 months when car sales were above 30.5 cars per month. Now we have 34, which is greater than 30.5, 38, which is greater, 40, which is greater, 40, which is greater, and 42, which is also greater. So that's how you interpret the data when it comes to median for ungrouped data, right? So are there any questions before we move on to the third one, right? I try to explain this as elementary as possible, but however, like I said, some of these things, some people will be seeing it for the first time. Okay, so I'm seeing some people that are saying they got it, so that's fine. So let me proceed, right? Okay, so let's look at the last measure of central tendency, which is called the mode. Now, this one is very easy to remember, this one. So the mode is the most frequently occurring score, or the number that repeats the most number of times. So when you are given like this type of data, 85, 48, 52, 64, 64, 80, and 75. So the most number of times, that's the mode, the number that's repeated the most number of times. That's the mode. So in this case, you see that 64 is repeated twice. So the mode is 64. Can you see? Now let me put another number here. So let me put 75%. So you can have a scenario where you can have numbers that are repeated the same number of times. And also that will be the most repeated number of times. Let me explain this by an example. If we check in this modified number, right? There are 2 numbers that have been repeated the most number of times. So there's 64% and there's 75%, right? There's 64% and then there's 75%. They are repeated twice, 2 times. So this will be what is called, it's very rare to have a question like this, but there's a reason why I'm explaining it, because I once saw a question, but it was asked once way back in another question paper, right? Was it question paper or KCQ? I don't remember. So this type of question, we have what we call 2 modes. So you can have a scenario where you can get 2 more than 1 modes, right? So you can have, let's say you have 3 numbers that are repeated the most number of times the same time. So let's say maybe another number also here is 85%. So you have 3 numbers that are repeated 2 times, and 2 times is the most frequently repeated time. So in this case, it will be 3 modes, right? So something like that can happen, right? So you also need to know that mode does not mean once. So you can have more numbers that are repeated the most number of times, and it will be the same number, right? So it means it has more modes. Then another scenario now where let's say we've got 75% here, right? Then we have another 64% here. So we are having a scenario where 64% is repeated 3 times, right? And we are having a scenario where 75% is repeated 2 times. So don't be confused by 75. 75 does not affect the mode because it's 2 times. We said mode is the number that is repeated the most number of times. So obviously 3 is greater than 2. So obviously the mode in this case is 64. So you can have some other numbers also that are repeated, but the one with the most repeated number of times, that's the mode. If all of them are repeated the same number of times, like like the previous example, where all of them that were repeated 2 times, then obviously it's a multi-mode answer. But if one of them is then repeated more than others, then those other ones, they are discarded, right? So that is another scenario there. But these are rare cases. But I said we need to cover for that in case maybe they can come. All right. So up until this point, I want to believe that I got everyone, right? So let me go to another section. I think let me just explain today using theory. Then next week, I'm going to repeat everything that I've said, but I'm going to show you some templates on Excel, right? Where, let's say, in case they come in the future, instead of you doing it manually, you can go to that template, right? So let me just finish, explaining this in theory without showing you. The next week, I'll show you the faster method. Now, the previous sessions, we were talking about mean, mode, and median for ungrouped data, right? Now, we are looking for mean, mode, and median for grouped data. So, what you need to understand is their formulas are different. That's why I took time to explain the difference between grouped data and ungrouped data, so that when you see the difference in formulas, you won't say, but Mara, we are just calculating the mean. Why is the mean having 2 different ways of calculating the mean? The reason why we are having 2 different methods of calculating the mean is the type of data that we are given. So if you are given raw data, you use a certain formula. If you are given grouped data, you use another formula. Right. So let's go back to the mean for grouped data. So this is data. This is raw data here. This type of data is ungrouped, right? It's data that is ungrouped, right? Then on the next slide, it's then grouped. So that type of data in the previous slide, it was then grouped into bundles, right? So the first bundle is 10 to 19. The second is 20 to 29. The next is 30 to 39. The next is 40 to 49. The next is 50 to 59. All right. So what you need to understand here when you are grouping, all right, is these values here. Okay, so let me explain this because I don't think, okay, let me share something here because I need to explain this because I might actually, all right, I might actually forget to do this. Just give me a moment. I think that would be the best way to do that. Just give me a moment right here. Okay, where is that thing? Where is it? I'm thinking of it now. I should have, let's say, prepared it before the do you call this? No, just give me a moment. Right. I'm looking for this document that will help explain this in detail. Okay, I think I found it. All right, so I think it's downloading behind the scenes. Okay, let me explain. Let me explain again. All right, so we have when you are grouping data, we have what we call a class interval. All right. So a class interval, right, is like this. An example, it's 10 to 19. So a class interval, we have three things, right? This I don't think this theory is there in your study guide, but I'm explaining this so that you understand, right? So it will have three things, right? One, it will have what is called the class width. The class width is the length of that class, right? It will be the reason why we are saying 10 to 19. There's a width right there. There's a width from 10 to 19. I'm going to show you how to calculate that class width, right? Then two, we have what we call lower class limit. Lower class limit, what it is the lowest value that can be achieved in that class. So if we say our class interval is 10 to 19, the lowest value that can be achieved in that class is 10. So that's the lower limit. So it's called the lower limit of the class. Or what is called, some they might call it lower class limit. LCL, lower class limit. It just means lower limit, right? Then three, we have what we call an upper limit, which is also known as upper class limit. What is that? That is the maximum value or the highest value that can be achieved in that class. In this case, that will be 19. Right? So the class width is the distance between, so the class width is the distance between the lower limit and the upper limit. That's the class width. That's the width of the class. So how do you calculate the class width? The class width, right? Normal sense would be like, you say 19 minus 10, then you get the class width, right? That's actually wrong. You don't do that, right? So when you are calculating class width, let me show this first. So all the values on the left side here, these are lower class limits, all right? All the values that are on the right side here, these are upper class limits, right? So there are two ways of calculating a class width. Now, if you don't understand what I'm talking about now, I would want you to ask a question, because there's one formula where we are going to be using class width right away. So when you are calculating a class width, you can either, the first method is you can use consecutive. I'll explain what it means. Hey, what am I writing? Guys, consecutive. I am hoping that this is the proper spelling for consecutive. Consecutive lower class limits. Don't worry, I'm going to explain what it is, right? Then the second method, so it's you choose either or, right? There are two ways of calculating the class width, so you have to choose one. I'm giving you both of them so that you can just have whatever you want to choose, right? So the next one is consecutive upper class limits. All right, what am I saying? Let's start with the first one, consecutive lower limits. So these classes are consecutive. So this class and this class, they are consecutive or neighboring, right? So the other name for consecutive there, you can put neighboring, right? That's why I wanted that document that I was looking for, because I had actually written down those definitions. So I could have just been reading from that document showing you, right? With the key terms. But unfortunately, I don't think let me just try again. I don't think I was successful. Let me see. Let me just try for the last time. Oh, I think I'm successful. Okay. So, all right. So let me see. I hope it's gonna download. All right. So let me just wait a while. So consecutive might mean neighboring, right? So neighboring, it means the classes should be next to another. So let me have this so that it won't confuse people. So this class, and this class are neighboring, right? Right? This class and this class are neighboring, right? This class and this class are neighboring. This class and that class are neighboring. So you can't say, if someone says this class and this class are neighboring, that's false. They are not neighboring, right? Because there are two classes that were skipped. So when you are calculating class width, right, it is only applicable, right? It is only applicable to classes that are neighboring. All right. So let me try to share this. I think we were. All right. So I think we were actually. All right. So there are these terms, right? Let me check what are you seeing? Okay, you're seeing the document. So class interval, right? It is a term that is used to denote the numerical width of a class in a frequency distribution, right? So in a grouped frequency distribution, data is arranged in form of classes. So the difference between the upper class limit and the lower limit gives the class intervals. So what are these upper class limit and lower limit, right? So the class limits are the lowest and the highest values that can be included in the class. So if you take, for example, this class 30 to 40, the lowest value of that class is 30, and the highest value of that class is 40. So the lowest value is called the lower limit of that class. The highest value is called the upper limit of that class. Now, when you get to class width, this is where I wanted this to. So class width refers to the difference between the upper and lower boundaries of any class. All right, this is not supposed to be and, it's all, right? It is the difference between the upper or lower boundaries of any class, all right, categories, right? So depending on the author, depending with who is explaining what a class width is, it's also sometimes used more specifically to mean, so you can choose either of these two methods. So the difference between the upper limits or two consecutive, meaning neighboring classes, if you subtract two upper class limits that are consecutive or neighboring, you get a class width. I'm going to show you on that table. Then the difference between lower limits of two consecutive classes, then it gives to that example there, right? So we are saying these classes are neighboring. So the lower limit of the first class is equals to 10, right? The lower limit of the second class is equal to 20, right? The upper class limit of the first class is 19. The upper class limit of the second class is 29. So when you are calculating class width, which is normally known as C, right? Which is normally denoted by C, you can either say it's lower class limit 2 minus lower class limit 1, right? Which means you can say 20 minus 10, because lower class limit 2 is 20. Lower class limit 1 is 10. So it will give you a class width of 10. Or, right, you can say upper class limit 2 minus upper class limit 1. Upper class limit 2, what is it? This is 29. So it can be 29 minus 19, right? You will still get 10. So regardless of whether you are using neighboring lower class limits or neighboring upper class limits, you will still get the same class width. So let me show you here. Let me show you here. So when you take these two neighboring classes, if you say 30 minus 20, you still get 10. If you take these two neighboring classes, you still get 10, right? Right? If you take these two neighboring classes, you still get 10. So it doesn't matter, right? Yes, that's a very good question. So someone is actually asking, so does that mean that the width will be the same for any category? Yes. So it means that the class width here it's 10, it's 10, it's 10, it's 10, it's 10. It does not change. That's actually a very good question, right? So the class width is constant, right? The class width is constant. So this is how you actually calculate the class width. Class width, you don't say 19 minus 10, because 19 minus 10 is what? It's 9, right? So you don't say, so class width, you don't say upper class limit minus lower class limit. This is wrong, right? This is wrong. So if a question says, what is class width? Either use this formula or use this formula. That's the one that will give you the true class width. This is wrong here. That is wrong. Guys, who's writing on the screen? There's someone who's writing on the screen. Please don't write on the screen, because now you see these values are now, those things are coming on the screen, and it will like it will affect everything else. All right. So now that I've explained that, right? So when now you have made your class intervals, your categories, right, or your bundles, you now group the scores based on the interval. So let's say two marks get into this class, 5 get into this class, 6 get into this class, 4 get into this, and 3 get into this. When you add all of them, they must give you the total number of people. Now the midpoint. How do you calculate? So now this is the full table. You know, last week we only talked about this column. We talked about this column and this column in what we were talking about when we said this is what is called a frequency table. And then we talked about this extra column when we were talking about cumulative frequency table. But for the sake of you calculating the mean, mode, and median, the longer way, right? The longer way, you need now three more columns, the midpoint, the fx column, and the fx column. So I'm going to explain what each does. So interval, this is your class interval, right? Frequency, this is where you group the people or the items. Then midpoint, this is calculated from this class here, from this class interval. So the midpoint is equals to the lower class limit of that class plus upper class limit, and you divide by 2. So what does it mean? For the first class, you say 10 plus 19, you divide by 2, and then you get 45, 14.5. That's why it's called midpoint. So you are adding these two, you divide by 2. So if you do for this, for all of them, this is what you get. All right. So I don't have time for that. But if you go and check, that's how they calculated them. So your frequency becomes F. Your midpoint becomes X. So Fx, what it means is you're multiplying frequency by midpoint. So if you say 2 multiplied by 14.5, you get what? 29. 5 multiplied by this, you get that. 6 multiplied by this, you get that. Then 4 multiplied by this, you get that. And this multiplied by that, you get that. Right? Then, when you get your fx, then you have your fx squared. So fx squared basically is like there are two ways of calculating fx squared. So the first one, you say fx multiplied by x, right? Or you say f multiplied by x
Kuda.
squared. Yes.
Okay, so before you continue, I don't want to
Yes,
lose
ma'am.
you.
You can go
Right?
ahead.
I'm just gonna ask you, please, can you just pick one of the other in intervals? Because I just tried now with the second one, but it doesn't give me that midpoint figure. So I don't know where I'm going wrong. Just one. Any.
Oh, okay.
Or maybe you can do
All
the
right.
second one, please.
All right. All right. So let's yeah, since that's the one that you did. So I think let me take that one. So here we say midpoint, we say 20 plus 29. What do we get? We get 49, right? When you divide this by 2, 2 into 4, you get 2. 2 into 9, it's 4 times. Because remember, 4 by 2, sorry, we get 8. So when we say 9 divided by 2, it's 4 times remainder 1. So that 1,
Okay,
it will be
but we
1 over 2.
don't,
So
but we,
2 gets
sorry,
into
but we don't,
9
sorry,
4.5 times, right?
sorry. I don't even know how to do that
Yes, yeah, you can go ahead.
division or whatever. But when you go into the calculator, it doesn't give you that number. And I think
Yeah.
that's where I got stuck.
Yes, it will give you 24.5.
Yes.
Yes. So 4.5, right? Half, basically, if you change it to a decimal, you get 0.5. So it will be
No, it
4
gives me
plus
34. Okay.
0.5 to get 4.5.
Okay.
So no, it shouldn't give you 34. I think you made a mistake. Are you sure you punched
Oh,
in
I see
29 or
now.
39
Apologies.
or
Apologies,
20 or 30 instead
everybody.
of 20? Yes.
Sorry,
Yeah.
apologies. It was just a finger error,
Yeah, yeah,
a
yeah.
typing error.
I
Thank
think
you.
the way, yes. If it's coming out as 34.5, yeah, then it means there was a problem in punching in. But thank you so much for bringing that up. Maybe there might have been someone also who might not have known how to really do that. So that's how they arrived to 24.5. But like I said, don't worry about the manual part of it, because in this module I'll give you what do you call it, templates, so that in case something like this comes, right? You have a template, you just punch in some values, and then Excel does everything for you so that you know you don't make those kind of mistakes. All right, so I explained how to calculate fx, right? Excuse me, of fx. So now we want to calculate fx squared. So in this way, fx squared, we calculate it by saying x multiplied by fx. So you multiply this by this to get that. You multiply that by that to get this by this to get that by that to get this, and so forth, right? Then cumulative frequency. So cumulative frequency, remember that example of that person coming through the houses picking up stones. That's one of the easiest way that people can remember cumulative frequency. You remember last week, right? That person who was coming through all the houses, picking up stones, putting them in a bag. So this is how you calculate cumulative frequency. So what you do here is the first one will remain 2. So this will remain 2. Then this 2 plus 5, you get 7. Then this 7 plus 6, you get 13. This 13 plus 4, you get what? 17. Then 17 plus 3, get what? 20. This is a shortcut. Remember, I'm just saying this because I know I explained it in detail, right? That's why I'm just rushing, because I explained it in detail last week, right? So I want to believe that all of you will remember. So that's how we get up to 20 there. So this will be the full table. You cannot calculate the mean, mode, and median manually if you have not created this table. This table is for you to be able to calculate this manually, right? Manually. So you can't proceed without this table, right? So, how do we calculate the mean? So once we have that table, okay, so let me go back to this slide. Well, once you get that table, what you're doing here is you add all the frequencies, you get this value. You add all fx's, you get this value. You add all fx squared, you get this value. These are the most 3 important values that you need in calculating this median and some other things, right? So let's start with mean. So the mean now for grouped data, you can see that the formula is now different from the one that we did, right? Because this is now different set, another different type of data, right? So it says, you see this E written in a weird way, all right? So this represents what we call summation. This is a statistical notation for summation or for sum. Sum meaning you are adding. So whenever you see this animal here, allow me to call it an animal. Whenever you see this thing here, they rarely do that. But I'm just saying, you know, it's something that is included in your study guide. So you need to know what it is. So what it means is you are adding. So in this case, what it means, it's you are adding all the values of fx's and then you divide by n. So that's why I say you are adding all these fx's. So you add all of this, then you get this total here, right? So summation of fx is equals to 700. Basically, that's what it means, right? So on the next slide, so we are saying x is the midpoint of the intervals and f is the frequency of the interval. We talked about this, right? So like I showed you, summation of fx is equals to 700. Then n, if you add all the frequencies, it's 20. So if you say 700 divided by 20, then you get your what? Then you get... Okay, someone is saying, but we're still waiting for last week's record and I was unable to attend to the end. Are you sure? Are you sure James didn't send in the group? Can somebody verify? Did James send anything in the group last week? He was supposed to send.
Oh,
He was supposed to send. And normally James sent. He didn't. Oh, apologies for that. I'll tell him, I'll tell him today to send it. Oh, okay. Apologies for that. I assumed that nothing received. Oh my God. He did not send. We asked multiple times. Unfortunately, yes, and unfortunate. But don't worry, don't worry. Ne? It will make sense if maybe if some of you guys did not attend until the end, all right? Even if, boss, what we talked last week, if you said you left at the end, then it means some of the things that we discussed last week at the beginning is what is applicable now. Some of the things that we said later is not applicable to what we're going to say. So don't worry much. You didn't lose anything at the end, which is affecting what I'm teaching today. Right. But however, for those that may want to recap, you can go and listen. I'll hear why he didn't send. You were supposed to send. You were supposed to send. I think he forgot. Apologies for that. I think he forgot. You were supposed to send, and then you also sent this one, right? So when you get these two, when you listen to it, then you can be able to combine these two. So this is how you will be able to. Okay, let's see. Can you please send the notes that you were sharing today? All right. I think let me share. I think I'll share them at the end, right? I'll share them at the end at the end. Just remind me when I say the lecture is done. We're almost done anyway. But when I say we are done, just remind me so that I can upload them now, so that James does not delay sending that to you. All right. So now let's get to the so let's calculate the median. Now the median is more like a bit difficult here, but remember, once you have that table, it's easy because now you are just plugging in values. So the formula there, I'm not so sure if you can see very well. It's ME, which is median, is equals to OME. I'm going to explain what it is, plus, then you say C, open bracket, N over 2, minus F less than, close bracket, over FME. So what does that mean? This OME here, this is the lower limit of what we call the median class, right? So what is the median class now? So the median class, it is the class, right, in which the median value falls into, right? So I'm trying to find a way to explain this in a much easier way, because normally I use Excel to do that. All right, so let's look at this example. How do you find what is called the median interval? So the median interval is the class in which the median value fall into. How do you find the median value? So basically you say n over 2. So how you calculate median here is different from how we calculate median on group data. So the median value is n over 2. So in this case, it's 20 over 2, right? And then you get 10th position. So how do you find the 10th position here, right? Now, I will need your undivided attention here. So we want to find which class in which the 10th position will fall into. So how do you check? So you use these two columns here, the frequency and the cumulative frequency. So how do you do that? So the first class, it has 2 frequencies, right? So if the first class has 2 frequencies, what will be the position of those frequencies? So it will be the first position and the second position. That's why we have 2 here. So this class, what it means, you are having 2 things that have the first position and second position. So since the first position and the second position are already taken, so it means that the next class, the starting position will be the 3rd position. So we know that we are starting from the 3rd position, right? How many positions are we going to add? Or how many positions are there altogether in this class? Then we look at the frequency. Then you see that there are 5 positions. So here you say, okay, so with the first position with the third position, then you say fourth position, then you say fifth position, right? Then you say sixth position, then you say seventh position. Why am I ending at seventh position? Is because of this number. So the last position should match this number here. But when you count all the classes, there must be 5. So you say third, fourth, fifth, sixth, seventh. There will be what? There will be 5 classes, right? Then, since the seventh, the first 7th position are already these positions are already taken by the first class and the second class. So it means the third class, the position that starts will be the 8th position, right? So how many now positions will be in that class? There will be 6 of them. So it will be 8, 9th position, 10th position, 11th position, 12th position, 13th position. Like I said, the last position should be the same as the number here. But if you check already, it means that our 10th position is in this class there. So that's how you determine. It's a really, this one now, there is no like an easier way of getting this. That's why I'm taking time to explain this, because Excel cannot do this for you. You actually have to do it manually, like what I'm saying. So you actually have to. The reason why I'm doing this, there's a faster way of doing it when you already know. But like I said, when I teach assuming that you guys don't know some stuff. So that's why you see I'm listing there. In the first class, we have 2 positions. In the second class, we have 5 positions, but the last position is the 7th position. So now I can already see, right? I can already see that the 10th position is in the 3rd class. So this is the longer way of doing it, where you list all the classes down. The faster way, because if you're already someone who already know this, you just come and look at this cumulative frequency. You look at these values alone. So by seeing 2, I can see that the maximum value, the maximum position is 2. The maximum position is 7. The maximum position is 13. So if the maximum position is 7, so it means the next class we have 8 to 13. So 10 will be in this class. That's the faster way of doing it. That's how I do it. Because I just come and check. Because like I said, the last position of the class is determined by this value here. So the last position is 2 here, second class. The last position in this class is 7th position. The last position in this class is 13th position. The last position in this class is 17th. The last position is 20th. So I can already tell 10th position is in this class. Why? Because if the previous class ended at the 7th position, so it means that 10 is here, because it's going to start from 8 to 13, which is proved by the longer method that I showed you, where you say 8 plus 9th plus 10th plus 11th plus 12th plus 13th. Right, so that is how you determine the median class. So the median falls in this class. So this becomes your median interval. This becomes your median interval, right? So when you have your median interval now, I know right now maybe some people's mind are like, I know you get saturated. Normally, I don't want to go beyond an hour. But today I was forced because we already started the other part. So I had to finish it. But like I said, don't worry, next week I'm going to repeat it again. But I'm going to repeat what I'm saying today using Excel sheet, right? The faster method. So don't worry, even if some of the things that I'm saying it doesn't make sense, I'm going to repeat it again next week. All right, so now we now understand what median interval is. So in this case, our median interval, I think it's 30 to 39. So when we say lower limit of the median class, you are taking this, right? You take the lowest value that can be achieved in that class. Then see what is it that is your class width. You remember the formulas, the formulas that I took time to explain about class width, right? This is where I was saying that you understanding how to calculate class width, why it's very, very important, right? Then N is equals to sample size, right? That's your N there. FME, that's your frequency count of the median interval. Then F less than, that is cumulative frequency count of all cumulative before the median interval. So what it means is, right? So this is the cumulative frequency of the median class, right? Let's say, so cumulative frequency normally is capital letter F. So let's say this is the cumulative frequency of the median class, right? So this class just before the median class, the cumulative frequency is known as F less than. So this is the F less than when they say N over 2 minus F less than. This F less than is this cumulative frequency, is the cumulative frequency before the cumulative frequency of the median class. So first, you need to identify which is the row of the median class. So when you identify the row of the median class, then you say, okay, so this is the cumulative frequency of the median class. Then the cumulative frequency just before it or above it, right? This one, that is before. Then this is the F less than. That's how you get your F less than right there, right? Then what you're just doing now, here you're just, when you identify those things, you're just plugging in it in the value. So let's now see how do we plug in the values right here. So ME, which is median, is equals to OME, which is the lower limit of the median class, plus C, which is the class width, open bracket, N, which is the sample size, over 2 minus F less than, this is the cumulative frequency before the median class, over FME, which is the frequency of the median class. So what you are doing here, let's find, how do we find OME? So our median class is this one. So OME, it's this value here, the lower limit of the median class. That's why there's a 30 there. Then what is C? All right. C, we say that C, either it can be LCL2 minus LCL1, or it can be UCL2 minus UCL1. So you can either take any of those two, right? So what you can do right here is you can just come and say, I'm taking these two. 29 minus 19, you get 10. That's why there's a 10 here. Then N, you add all the frequencies. When you add all these frequencies, you get 20. That's why there's a 20 there, right? Then divided by 2, 2 it's already, there's just a constant, minus F less than, remember, the cumulative frequency of the median class is 13. So F less than, we take the one below, the one before the class, which is 7, the one in blue. So that's why that's the 7 there. Then FME, that's this 6 here, the frequency of the median class. When you find the median class or the median interval, then you take that 6 there. So once you identify your median interval, then it's easy for you to substitute in values for that formula. That's why I was saying you cannot calculate the mean, mode, and median without this table here. All right, without this table. I think for tonight, let me end here. I'll end up confusing people. Then next week, before we start the examples, I'll start by explaining the mode, and then we'll get into the Excel sheet, right? So I think for tonight, let me end here, and let me open up for questions. I know you may have more questions on what we were doing on the median. So let me see, is that a question? Okay. All right, so I'm not so sure if you understood what we were talking about on the mode, on the median, but like I said, I'm going to repeat it again, right? I'm going to repeat it again. Today I was just showing you by just trying to explain the concept. And I know right now your minds are so saturated because we started, with calculations, and now 1 hour 30 minutes later, we are still we are still we are still unpacking certain things. But like I said, don't worry. I'm going to repeat each and everything that I said today. I'm going to repeat it again next week, but I'm going to repeat it when we are using the faster way, when I'll show you the Excel sheet, right? And then I'm going to repeat again. This is the median. This is what we were talking about last week when we were talking about this and that, this and that, this and that, this and this. So for tonight, I think let's end here because I'm afraid that if we continue and go to the mod, it will be information overload. Like at the end of the day, I'm not here to, like I said, we are here to make sure that each and every person has to understand. So there's no need for us to rush, when I can see that, this information might end up confusing people rather than benefiting people. So I think let me end today and then we'll continue next week. Or someone saying, hopefully we'll get it this week and revise. Just want to know how to get it there. Oh, all right. No, that's fine. I think I'll try. Okay, that's fine. I think it's okay. I think, let me remind James. I think he forgot. Normally James sends. I'm actually shocked why he didn't send, but I'll remind him. I think he had a lot on his table, right? Since most people are now opening, so I think he forgot. But normally he's actually the one who, but now, right now we record on the cloud so that, because back then he used to come and chase me, give me the slide, give me the recordings and things like that. But now we are recording on the cloud, so he can get it on his side. So I'm actually shocked that he didn't upload. So apologies for that. But I'll remind him. However, there were people that were asking for the slides. Let me try to. So while I'm uploading, if there's someone with a question, please, just ask. Like I said, don't worry. If you didn't understand some of the things, I'm going to repeat. And next week it will be easy. It will be way easy now because I'll be showing you the faster way of it. So next week will be very interesting. That's actually most of the most part of my lectures that people like, because people like things that are easy. They don't want complicated stuff. I remember there was another class where now they were saying, don't tell us the longer method, just give us the shorter method and then we'll go, right? Because it makes life easier. But the reason why now I start by explaining the manual method is we want people to understand the fundamentals, right? We want people to understand the fundamentals. That's why we explain things from so someone is actually saying was fun. Hopefully stays like this till exam. Yeah, that's actually how we do it. That's actually how we do these lectures. That's actually that's one of the reasons why I actually ended here. Cause normally I don't want to go we don't want to do states for 1.5 to 2 hours. I know I've done that before and I see that a lot of people will have their mind saturated. So they'll just be there in the class, but their mind have drifted away. So normally I only take almost like an hour. We teach a concept, then we show the manual method, then the faster method, then we close up until we get to the exam. When we get to exam revision. So when we are doing exam revision, I don't actually show manual method. I'll just tell you this question. Okay, this is this part of the study guide. You use this template here. This question you use this template. This question you use. So it will be very funny and it will be very, very fast. All right. So I have shared. Okay. Are you seeing anything on the? I shared something. Are you seeing anything? Oh, it's loading. Okay. Just give me a moment. It's loading. I'm actually okay. All right. Someone saying no. Yeah, exactly. Nothing exactly. Because I'm seeing right now that it's actually loading. I uploaded this lecture. So let's see. I think it's almost done. In any minute from now, it should be reflecting. Yeah, perfect. So can you check your chat, right? The chat box. There's ADBM leg 1. So that's actually the full slides up until some of the things that we haven't covered as yet. So if maybe there are some of you guys that wants to go ahead and learn certain things, you can actually see the other things that we're going to cover in that lecture unit, right? So for tonight, guys, I think let's end here. And let's meet next week, same time. Then next week, we're going to continue briefly where we left. And then we are going to get into the faster ways of getting those answers. But for tonight, that's all that I had for you. Thank you, guys.
Thanks, Buddha.
Have a lovely evening. Good night.
Goodbye.
All right, thank you, sir.
Thank you.
Kuda.
Bye.
All right.
Good night.
Good night.
All right.
Good
Good night. Good night to you too.
Bye, you.